Hello all, welcome to the lecture series on Python and Scientific Python course. And in this lecture, we'll be learning about container data types in Python. Container data types in Python are having the ability to store multiple values in a single variable. In Python, instead of creating many variables, we can group data using containers. The data may differ based on order, based on mutability, and also we can be able to duplicate the data. Okay, so the main type of container data types in Python are lists, then tuples, then set, and the last one is dictionary, right? So we'll be dealing every single type of these container data types with a suitable example, with a suitable programming example indeed, right? The first type of container data type is list. List is always an ordered and mutable collection of data. Mutable here, it means we are able to, we'll be able to change the values that are available in the list. Okay, so mutable means the changing of data, which is, if a list is already declared, if we have to change the data that is available in the list, it is allowed in the list. Okay, immutable in the sense, changing of data which has been declared already is not permitted. So list is always an ordered collection of data, and it also allows changing of data when you process the list. That is why it is called as mutable data. Okay, so let us see the how to work with an example in this program. So here I am creating a student's data in the form of a list. So list is always written inside the square bracket. Okay, so whatever the data that is to be collected inside the bracket are separated using a comma. So here I'm collecting students data and the names of the students. So it is, the names are already instinct, so hence I write them inside the quotes and separate them with a comma. So this is a list with the names of three students. Okay, so the list is created now. Now, if you have to access the elements in the list, you can access them based on the index positions. Always the index positions of each and every element in the list starts from 0. So if I have to access the element of index position number 0, I can use a print statement and call my list variable students and mention my position of the index, and if I run, it will print the value that is index in, that is in the position number 0. Yeah, so here in index position number 0 I have the name Anu, so Anu is printed. Supposingly, if I change the index position to 2, it is expected to print the value Chitra, hence it is printing. Now let us see how mutable, how lists are mutable. Okay, so it means mutable in the sense modifying the elements in list is allowed. How to modify? Okay, how are we going to modify the elements in the list? For example, I have only three students name here. I have to attach one more data to it. So I can use the syntax called append. So students is my list name. So in this student list, I have to append a new name. Append will always add the new element to the last position. Okay. So append of the new name. What am I going to add? Let me add Dinakar. Okay. So this is my new name. Okay, if I try to append it, you could see, and then I have to print the student list again. It's what, print students. Now it will print the new list. You could see Anu, Bala, Chitra and Dinakar. Okay, this is the new student list. For example, if I have to replace I can replace it based on the index positions. I have to replace Bala by some other name. So the index position of Bala is 1. So students of 1 should be replaced by a new name, maybe Bob. Okay. Then again print students. Okay. So now you could see Anu, Bob, Chitra, and Dinaka. This is why we say we are able to change the elements of the list at every single instant of time according to the requirement, and hence lists are always called as mutable. Means lists are always ordered, means that it always starts from the index position number 0. Mutable in the sense we are able to change the values, and it also allows duplicates. For example, in the new list, in the same list, I am creating a one more girl name with the same Chitra. Means I'm duplicating the element here. So now if you could see, I'm like I can just print the students. You could see the first element is Anu Bala Chitra Chitra, and after appending it is Anu Bala Chitra Chitra Dinakar. After replacing it is Anu Bob Chitra Chitra Dinakar. Means I have Chitra name twice. Duplication is allowed in list. Okay. So what is the use case of using list? The main use case of using a list is it can be used for storing data, especially in the case of student names and mark list. Okay. Right. Now the second container data type is a tuple. Right. Tuple are always ordered in the sense the elements inside the tuple always have the index positions from 0, but they are immutable. We cannot change or replace elements in the tuple which is already created. Okay. We can see that with an example. For example, I am creating a tuple called coordinates. The tuple variable name is coordinates. Tuple is always written inside a parenthesis. Okay. So 10 comma 20. Right. So this is my tuple. Now if I have to access print of coordinates of 0, it will print the zeroth coordinate element 10. For example, let us try coordinates of 0 is equal to 12. I'm trying to replace the elements inside the tuple in the index position number 0, which is already 10. I'm trying to replace 10 by 12. Okay, let us try whether it is working or not. It will not work. It says an error, it shows an error. The tuple object does not support item assignment. Means this is not supported by tuple because tuples are always immutable. You cannot change any elements inside the tuple if it is already created. Okay, hence this line will not work. Right. So tuple is similar, maybe like it may look similar, but it is immutable. Okay. The next type is a set. Sets are quite different. They are unordered. Also, it does not allow duplicates. In the first case, when we dealt with list, we had two names repeated, right? Chitra is repeated twice, means duplication of the name Chitra is allowed. But in set, duplicates are not allowed. Set, we'll deal that with an example, programming example. Let me create a set named numbers. Sets are always written inside the flower braces. So let me define the elements in the set as 1 2 3 4 5. and I'm trying to print them. Okay, if I try to print, yeah, you could see it is printing the numbers. Also, if I wanted to add a new element, I can add it. New add of 5, right? And maybe like out of 6. Now again I try to, sorry, now again try to print the same set, right? If you could see, it is adding the new element 6. Supposingly, I'm trying to add same 6 again. Okay, trying to add 6 again. Let us see whether duplication is allowed or not. You could see duplication is not allowed. As per the program that is written, it should be 1, 2, 3, 4, 5, 6, comma 6. Okay, it does not allow duplicates. Hence, it is not adding 6 again. But if I give 7, it will print. Okay, duplicates are not allowed. Okay, sets or automatically they'll be removing duplicates, and they don't have index, therefore don't follow indexing. Always they are unordered. So every n number of times you run the set, the elements are unordered, they don't follow the index positions from 0, right? The next example is, sorry, the next container data type is a dictionary. It's very interesting thing, concept indeed. So a dictionary will always be represented as a key value pair. Okay, data must be stored as a key with its value. Okay, keys must be unique, and we can access the elements based on the key values. For example, let us see this particular code. I'm creating a dictionary called student. Dictionaries will also be written inside the flower basis, but provided they will have a key with its value. So here the key is name. The value for this key is Anu. This is the first element. Second element can be written with the comma. Name may be age 20. Third element may be marks, maybe 75, and I close it. Now let me print, access the element, print of student. Student is a dictionary name. If I have to know the name of the student, I should access the name using the key. The key, sorry, this should have, yeah, the value for the key name is Anu. So hence, if I wanted to print Anu, I should access Anu using the key name. Here we don't access the elements based on index, instead we access them based on the key. Okay, so print student of name. Similarly, if I have to know how much marks Anu have secured, sorry, if I have to know how much marks Anu have secured, I have to access them based on the value marks. Finally, print student. This dictionary has to be printed. Okay, shall we see? Yeah. Uh, does the error? Sorry, this is a string. Now it will work. Could see. Supposingly, if I have to, it says the name of the student is Anu, the mark secured by Anu is 75. For example, if I have to replace the mark 75 by 90, just replace it and then print it again. This is, sorry, this should not be print statement. Okay, this is just a refresh. Yeah, now you could see name is Anu, age is 20, and her marks is 90. Okay, right. So if we have to make a quick comparison on list, tuple, set, and dictionary, you can make them based on how ordered they are, whether they are mutable, and whether duplicates are allowed or not. Okay, so now let us practice few examples to just revise on whatever we have learned till now, right? Let me create this container data type and just recall yourself and tell me what type of container data type is this. This is s, yeah, this is a list, correct? Okay, so in this list, if I have to slice the elements, okay, so if I have to slice, I can slice them based on the index positions, maybe like print of data. I can slice them from 1 to 2. 1 to 2 in the sense, this is the starting index position, maybe 1 to 3 I can have. Always slicing supports from if I have to slice, it is going to slice from 1 to 2, because it always starts from starting position, and this end position, end index position, is at the exclusive number. Okay, so if I give 1 to 3, it will slice from 1 to 2, means from 1 to n minus 1 it is going to slice. Okay, so if it is like that, you just check it. Slicing should be of this basis, yeah. Okay, this is how slicing will work based on the index positions. Okay. In sets, you can also perform the mathematical operations like union, intersection, and difference. Let us see an example for that one. Let me have a set called A and other set called B. 1, 2, 3, 4, maybe 3, 4, 5, 6. And now I have to perform union, intersection, and difference. So union is A or B, yeah, uppercase. Then print A ampersand, ampersand B is to find intersection, and difference is A minus B. These operations are allowed in set. Set operations follow mathematics, right? So it is allowed. So intersection, union is 1, 2, 3, 4, 5, 6. The duplicate is not allowed. 3, 4 is not repeated. Intersection will find the common elements between A and B. 3 and 4 is found, and A minus B is finding out the difference, right?